This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Before continuing, please see video on hypothesis testing. This example is based on the 2015 Higher Level Leaving Certificate Question 2B. The question states that a survey of 100 randomly selected shoppers at a supermarket showed that the mean shopping spend was €90.45. The standard deviation of this sample was 20.73. The supermarket has claimed that the mean amount spent by shoppers on a Saturday is €94. Based on the survey, test the supermarket's claims using a 5% level of significance. Clearly state your null hypothesis, your alternative hypothesis, and your conclusion. Our first step is to state the null hypothesis and the alternative hypothesis. Our null hypothesis is a claim or statement about the population parameter, and it is assumed to be true until it is declared false. In this case, the supermarket has claimed that the mean amount spent by shoppers on a Saturday is €94. So our claim is our null hypothesis. The mean spend is €94. The alternative hypothesis is then the mean spend is not €94. Before continuing, I'm going to tidy up the slide. For our test, we are going to use the test statistic Z equal to x bar minus mu all over the standard deviation divided by the square root of n. From our question, we can see n equals 100. Mean shopping spend was 90.45. So this means x bar equals €90.45. Standard deviation is equal to 20.73. And our mu value is given in the claim. It is €94. Now we fill into our formula. So Z is equal to 90.54 minus 94 all over 20.73 divided by the square root of 100. And when we do that calculation, we get an answer of minus 1.71. Our next step is to define the rejection region. In this case, we are using a 5% level of significance. From our normal distribution table, we will find that the 5% level of significance is equal to minus 1.96. Please refer back to the video on how to use the normal distribution table. This minus 1.96 means that if our z-score is less than minus 1.96, we reject the null hypothesis. Alternatively, if z-score is greater than minus 1.96, we fail to reject. Our null hypothesis. In our case, minus 1.71, our z-score is greater than minus 1.96. Therefore, we fail to reject the null hypothesis. Or, alternatively, you could say that there is not enough evidence to reject the null hypothesis. This question could also be done by using confidence intervals and finding whether our mean value of €94 falls within the confidence intervals. If the €94 falls within the confidence interval, we'd fail to reject the null hypothesis. This concludes the example on hypothesis testing for the mean.